Okay, we're back at it. Okay. So Connie, the reason why we're using d dy is because the question asks us to compute dx dy. If you go back and you look at the original one, it said do that one, not dy dx, dx dy. So for this one, let's break this down into steps as well, just to make sure we don't make any mistakes. So it's the derivative of the outside function, which in this case is just e to the x, evaluated. Sorry, I accidentally hit the power button. So it's going to be the derivative of the outside function, evaluated at the inside, times the derivative of the inside function, like this, right? And we just keep, like an onion, we just keep unraveling into the layers slowly. So we're going to get x e to the xy. I have to product rule this thing again. So I'm going to get derivative of the first times the second plus the first times the derivative of the second, which is just 1. And there we go. I've now completely differentiated this. E to the xy plus x y e to the xy dx dy plus x squared e to the xy. Now I'm trying to solve for dx dy. Actually, here's a trick, okay? So at this point, everyone, you probably want to solve for dx dy. I'm going to do that for you, but I'm going to show you a trick after, okay? So remember this line right here. So let's solve for this. So anything that doesn't have the dx dy in it, I'm going to move over to the other side, right? So I'm going to get negative x squared e to the xy. And I'm going to factor a dx dy out of this term, dx dy e to the, I guess I could factor out an e to the xy too while I'm at it. xy, 1 plus xy e to the xy. And then I'm going to divide by this thing to find that dx dy is negative x squared e to the xy divided by e to the xy, 1 plus xy.
I was going to say, why do you have another e to the xy?
Why do I have? Yeah, that should just be...
Just xy.
Yes, just xy. Thank you. The e to the xy's cancel each other out, so I get negative x squared all over 1 plus xy. Now I'm going to plug in x equals 2 and y equals 0 into this, right? Because it asks us to find it at those places. That gives me negative 4 divided by 1 plus 2 times 0, and that is negative 4. And that was answer A. Okay. So I'm going to give you a second to process that, and then I'm going to show you actually a slightly easier way of doing this. Could you explain the square bracket in the second line once you're done? Sure. So this one. Okay. So yeah, all right, so this is the one we're doing. Let me just make this yellow. All right, how do we want to do this? So I'm computing d dy e to the xy, right? Okay. Yeah, exactly. It's the chain rule. E to the xy. Yeah, and Aziz more or less has it. So it's like our outer function. Maybe let me even just kind of like write this as x xy, just so we can kind of see like what the inner and outer functions are, right? And so that's going to be, x prime xy times the derivative with respect to y of xy. Does that make sense? Do you see how it's the chain rule if I write it like that? It's the derivative of the outer function evaluated at the inner function times the derivative of the inner function. And the exponential function, which I'm writing here as x, is just its own derivative, right? And that's exactly what is in that bracket. Yeah, x is just me doing, that's just me writing this as a function so that you all can see like how it's behaving as a function, right? I'm not doing anything like crazy there. I'm just calling it a function like that so that you can all see how it operated. All right, Connie, how about if I did this instead? So what if I said f of x is e to the x, and then just replaced, so we would get the derivative of e to the xy is the same thing as the derivative of f of xy That's going to be f prime. Like that. Okay, Connie, does that make sense? Right, so if f of x is the function e to the x, it is its own derivative, right? F prime is e to the x. So does that clarify that bit? That helps, I hope. And I have another direct message saying, how does dy of x equal dx dy? So remember, when we do this, we're pretending that x is a function of y, right? And so what do I get when I do this? I get like x prime of y, right? Or equivalently dx dy. That's the same thing. Yeah, and exactly as he says, don't just like create an f and then because the TA will have no idea what you're doing, right? But if you say let f of x be e to the x, it might make things a little bit easier. Yeah. Okay. No problem. Now, everyone, as a little bit of a hint, this process of solving, a lot of mistakes happen here.
Mm-hmm.
Right? And you can see why, right? Like there's a lot of manipulation. You're adding and subtracting, you're factoring, you're dividing. Lots of mistakes happen here. So what we're going to do instead is I want you to look at this line, right? So this is 0. Okay, so I want you to take a look at this line here. And instead of solving for dx dy at this point, and then solving in and plugging in x equals 2 and y equals 0, let's plug in x equals 2 and y equals 0 at this point, okay? So if I do that, plug in x equals 2 and y equals 0, what do we get? So we're going to get 0 is dx dy e to the 0, right? Because it's x times y, plus 0. Well, here, maybe let me include everything just so that you can see what I'm doing. Plus 0 times 2 e to the 0 times 2 dx dy plus 2 squared e to the 0 times 2. And what you see is there's a lot of cancellation here, right? This whole thing is just 0. All these e's are just 1. So what do you end up getting? You get dx dy, right? Plus 0 plus 4.
Mm-hmm.
And now it's really easy to solve for dx dy, right? And Connie, yeah, sure, definitely we can, right? And you get the same answer, right?
That's correct.
So especially in these cases where you're being asked to find the derivative at a point, it is often easier to, instead of solving for dx dy, to plug your values in as soon as it makes sense to, right? Like once you finish the differentiation and you can plug those values in, you're free to do it then, and then to solve the equation and you'll get the right answer. And this often makes your life much, much easier than if you solve for dx dy to begin with. A lot of things will probably end up becoming 0. Okay, that's just a great way that these things work out. Okay, so are there any more questions? I know, so Connie wants us to do another one. I have another one lined up even as a poll question. No, I lied. I don't have another one lined up, but we can just make one. Here, let me just make one up. So Connie, do you want one that has like a number in it too? Like find, dx dy. How did I juke you? What did I do? Right? I'm just trying to show, like, the point is that as soon as you can plug in a number, you should, right?
I would plug the number in right away. I wouldn't do any of the solving steps unless the question was asked to find that dy dx explicitly. I would just plug the number in.
Yeah, right? Like, just make your life as easy as possible. Some students don't quite have the confidence to realize when they're allowed to plug the numbers in. They kind of like plug the number in at the very end. But yeah, as soon as you're done differentiating, you plug the number in. Okay, sure, Connie. And Kayla, sure. I feel like Kayla for you as well. Oh, okay, there's lots of things coming in here. Kayla, I also did something like this in office hours on Tuesday. Were you here for that? I don't remember. Okay. You might want to look at that first. Let me actually hunt it down for you, okay? Because I'm not just gonna be like, go look at it. But let me see if I can hunt it down for you, and you can take a look. Because we did one that was actually really, really close. And then Samantha, give me a second here, and I'll take a look at that one too. Actually, you know what? Let me make up a question, and then that way the class can kind of work on it, and I'll do some stuff.
Otherwise, I'm probably gonna head out right now.
Okay.
You work on that.
Yeah. See, Aziz.
Yeah.
Okay, let me see. Let's try and make something that isn't super easy. Because I assume you guys want like a medium range one, right? Like not one that's probably too easy, but not one that's too hard either. Let's do something like, these things are hard to make up. So let's say find dy dx when x equals 1. Let me actually just put a 2 here to make it easier. Okay, so Connie, why don't you just try doing that one? Let me next thing I'm going to do, Kayla, I'm going to try and get you that video, and you can look at it. And then that way, if by the end of watching that video, you're still not happy, you can ask more questions. But, and it's not because I don't want to answer your question, right? I'm just trying to be efficient in answering questions, but I'm more than happy to answer as much as I can. Where the heck is it? There it is. All right, so share, start at, copy. Okay, so, all right, so Connie, do it both ways. But so what dy dx is, here, maybe let me expand on that. So dy dx. So when we write this, what we're saying is we're pretending that y is a function of x. Pretend that y depends on x, okay? And so what you could do if it makes your life easier is you could take your equation and everywhere you see a y, just kind of write it as a function. Actually, I think explicitly in the video, I actually just put a function here. I say, you know, pretend that y is equal to f of x. And then everywhere you see a y, just put a function in. And now differentiate that with respect to x. Does that make sense? Okay, so try that, okay? And like maybe start here. And then try and do it in this notation, because the question in yellow here is a little bit clunky. You don't really want to carry around the F's. Again, if this helps you, by all means do it, right? Like don't feel like you should try and stick with the Y notation. But notationally, it's a little bit easier to just keep it in terms of Y's. So maybe start with the yellow thing, then try the white thing and see if you can get the same answer. But the math is exactly the same. There's nothing tricky here. It's just notation, right? Kelly, yeah, your matrix shouldn't be that, like, what do you mean by weird? Did it have fractions and stuff in it? Okay, sure. And then, okay. So Samantha, you were doing, oh, interesting. I like this. I like this a lot. Yeah, Samantha, that's totally legit. That is totally legit. That is a great solution. I really like that. That's very clever. That's a really good solution. All right. You should not hesitate to share that with the class if you want. That's a slick way of doing it. 100% okay. What you did was 100% correct. Very, very clever. I like it. Okay, let me download this, Kelly. Okay. Yeah, I got something pretty similar, but yeah, that's not right. Kelly, you shouldn't have all zeros on the right there. That's something's, wait, should you? Oh no, you need a fifth equation. So Kelly, I don't think you've accounted for, remember, you have to be f of 0 is equal to 1, right? Did you build that in? Yeah, because certainly if you don't have to go up, right? Like your polynomial has to go up and be 0 or be 1 at 0. If you don't require that to be true, the easiest answer is the 0 polynomial, right? It totally connects them. But you didn't include that condition where it has to go up. As soon as you include that, you'll get your answer. Yeah. What does it mean again when your matrix is all zeros in the last line? It just means that there was redundant information, Curdy. Like that's all that means. And so your equations, you had like 2 equations that gave you the same piece of information, right? Yeah. If we deal y as f of x, then we find f prime of x. Right, exactly. Yeah, Connie. Yeah, f prime would be dy dx. Those would be the same thing, and that's exactly what you're looking for. Factor out f of x and use probability of explaining the process we could use. Saim, I'm not certain which thing you're talking about. And Namir, so Namir, can you give me the answer for just f to the power of f for the 137 question? I don't want to give it away because I don't want to spoil it for the other students if you can. But like, again, if you want to take a picture and send it to me, I'm happy to check. Or tell me what you got if you just did f of x to the power of f of x. Because if you do this correctly, you can probably do the combined. And Abby, yeah, absolutely, you can use matrices. Anything from prior into the course is fair game. Right? You should use any tool that's available. Yeah, 100%. If you don't want to use matrices, you don't have to. That being said, you're going to get 5 equations and 5 unknowns. So, I mean, if you don't use matrices, it could be a little bit tough. I mean, if you can find a way to bring annuities into this, power to you. Like, go crazy. But yeah, you can definitely do other things if you want. And matrices are super useful, right? Like, again, I think most of you will see matrices in the assignment. And it gives you this idea that, yeah, sometimes you have to solve equations for unknowns. And this is a really important thing. And especially if you guys go do any stats, like if you did regression modeling. And what regression modeling is, right, is when you have like a bunch of data and you're trying to find a curve that fits that data. That stuff's all linear algebra, right? And it's the sort of linear algebra I'm actually having you do in this problem. In this problem, it's a little bit different. We don't have data, but it's the same sort of thing. You've got a bunch of restrictions on your function, and you're trying to find the coefficients of your function, which most accurately model that data. And that's a very important thing to be able to do in real life, right? So Connie, how's it coming with this one? Are you confident enough to give an answer? I mean, I haven't worked the answer out, so I'll have to do it myself. But I want to give you a chance to do it first before I go through this one. So when you're ready, just let me know and I'll go through it. It could be, I haven't worked it out myself, and is equal to 0, right? I assume you probably just hit enter too soon. Well, f of x is just y, right? Yeah, like fx is y, so you can replace it with y if you want. Here, Namir, let me download this. And now what you need to do is you need to find what y is. So I've given you x. What is y? Right? So I want you to plug x back into the original equation and solve that equation for y. It's a JPEG. That's why. Damn it. No, Namir. And I think you made the same mistake all the 137 students did as well. You took ln of the whole thing, right? Yeah, and you can't do it. Right? Because you don't know anything about ln A plus B, right? Like this is not, you can't do anything with the plus sign in the ln. So you don't want to take ln of the whole thing, but that's okay because you know that the derivative of a function plus another function is the sum of their derivatives. So you can differentiate them separately. Do you know what I'm saying? Yeah. So try it again, right? Give it a shot and see what you can come up with. Nice. Connie, right? Ln 1 is 0. Yeah. If we're not using the matrix way of solving equations, do we have to show all the steps? I would say no, but that being said, Ariana, like you should probably just use a matrix, right? Like if you don't have to row reduce, you can plug it into octave, right? So you don't have to, so just go do that, right? Make your life easy. I came up with 6 equations. Why, Brandon, I don't think your 6th equation is necessary though. That very last one. Why would that need to be true? I mean, it's fine. The solution does actually give you that, but you just have redundant information. There's no reason to enforce that last equation is true, right? Because no part of the question requires it. So again, it won't be an issue. I think it just adds redundancy because it does end up being true for the solution. But as a general rule, don't include more than you have to because you could have actually imposed a constraint that gave you an inconsistent system, right? But if you use that, I think it's fine, right? Like I don't think we wouldn't deduct marks for that. It's just unnecessary. Okay, so Connie, let me try it out now. We'll see if your answer is. Kelly, for what? Oh, okay, good. You sent me a thing. Why is that? What's bugging you about that, Kelly? I mean, maybe it works, maybe it doesn't, but you can plug that into Desmos and see if it gives you the right curve. Though notably, the solution you got does not agree with what you just gave me because you're skipping the 1 at the end. Okay, so why wouldn't C not be 1? Oh, because it obviously doesn't give you a correct solution, right? Is what you're saying. Okay, let me just quickly look at what you did and see if there's an obvious. I'm kind of going by memory here. That's equal to 0, yes. That's equal to 0, yes. Okay, so Kelly, I'm looking at, okay, so your first column is C0, your second column is C1, your third column is C2, yes? Okay, your third equation is the derivative at -1, right? So let me just double check here. X cubed, yeah, that's right. And then, yeah, this should be Let me just check something here. I don't see any obvious issues. Let me just compare it to what I got really quick. Oh, there's a typo. Oh, that's the next assignment, not this assignment. All right, let's compare these two. My screen's getting really, really small. Okay. Kelly, I need to see what you had before you RREF'd it. Can you send me the matrix before you RREF'd it when you added that last thing? And when I do the question, just replace f prime of x. You're right, Connie. Yeah. So I'm gonna Kelly. What? Okay. You sent it to me fast enough. So Connie, I'll do this in a second. Just let me double check Kelly's stuff here, and then. Whoa. Kelly, you told me your first column was C0, right? And your last column is C4. So look at your last row. What equation is that? Do you see what I'm saying? Like what's the right, what's the equation that last row is supposed to be? Because what you've written there is C4x to the 4 is equal to 1. Or C4 is equal to 1, right? But that's not what that equation should be, right? So your last row is incorrect. Just because you put the 1 in the wrong spot. Yeah. Do you see what I'm saying though? Like how it seems like you just kind of forgot which column was which and you put it in the wrong spot. Like you knew it was either the left or the right, but you put it in the right instead of the left. Okay, yeah, and then try it. I got confused at the point where we found the derivative. Okay, sure. Kayla, let me do this one first because I promised Connie I would do it for a long time. And then we'll come back and we'll do yours. All right, so Connie, do you want me to do the f of x version or do you want me to do the original version? Original? Okay. So we're computing dy dx. So what I'm going to do is I'm going to have, I'm going to differentiate on both sides. Now the right-hand side is 0. So I'm just going to start with that. Okay, so I'm just going to put that in because I just want to get it out of the way. Now I'm going to get 2 times 3x squared y plus x cubed dy dx plus, and then I have to product rule again. So I'm going to get dy dx ln x plus y over x. Does that look like what you got? Cool. And then you're done, right? What'd you get for y? I think it's 1. You got 1.5. Did I screw that up? So when x equals 1, you get 2y. Oh, yeah, you're right. It is 1.5. Yeah, it's 3 halves. I tried to make the number nice and I ended up making it worse. Right. So yeah, and now you just take those and plug it in. So if you got this, you're perfect. You got the right value of y, you got the right derivative, you've got implicit differentiation. Now, if you want to practice, I'd suggest now trying to do the other way, dx dy. Okay, try that one and see what you get. But yeah, if you got the correct derivative there, you're 100%, you understand implicit differentiation. Yeah, it's fine, Connie. You can do it. Just make sure you clearly say that, right? Like you say, let y be, no, but you have to state it, right? Like if you say, like what I wrote here, let y equal f of x, like that, and plug it in, totally fine. Yeah. Yeah, Brandon, if that happens, then you either put it into the equation, either put it into the matrix wrong, or your equations are wrong, right? So you can send me what your original matrix is, and I'll take a look at it. Kayla, so, and I got to the point where we found the first derivative of the given equation. Okay, so you're comfortable up to where we found the slope of the tangent line, and you're saying the tangent line itself bugged you? Kayla, is that correct? Okay. So I'm kind of going by memory here, but so yell at me if I get something wrong. So our function was f of x equals 1 over x, right? And let's say so did I do the derivative in general, or what was it when I was doing it at 1? I don't remember if I did it in general. I feel like I probably didn't. Well, why don't we do it in general? Okay. So we know, right? We know that f, maybe, and let me just kind of redraw it again. So we have it. Okay. So we've got something like this. So we know f prime of x is negative 1 over x squared, right? And I'm going to differentiate at some point a. And so the slope of the tangent line is negative 1 over a squared, right? You agree? Everything makes sense there, hopefully? Try and draw a straight line, but does not draw well. Like that. Yeah, that wasn't too bad. Okay. Kayla, so far so good? Okay. Now, so this is the slope of the tangent line, right? And what I need to do, though, is actually find the equation of the tangent line, right? So we need the equation of the tangent. And I wrote earlier, and in the geometry of the derivative section, the point slope formula. Okay, so the point slope formula is this. And so what it says is, if you know the slope of your line, and you know it passes through the point x naught, y naught, then you can just plug your numbers into this formula, and that will give you the equation. Okay, so the slope of this line is negative 1 over a squared. We also know that the line passes through this point. Can you tell me what the x and y coordinates are of this point? Not quite yet. No, yeah, let's not worry about base and height. Shanayu, yeah, exactly. So it's a1 over a, right? Why is it x minus x naught? Sure, let me explain that minus sign in a second. That's a great question. But this is a1 over a. So, okay, right. So remember, the graph of a function, this is x f of x, right? Like the y value keeps track, like y is the output of f of x, right? Yeah. So is everyone, and Kelly, you're okay with that as well, right? So if this is a, then this is f of a, and f of a for us is 1 over a, right? So the points on the graph, right? Like if this is, the point 1/2, then that point is 2. And if this point is 3, then it's 1/3, right? Like, yeah, right? That's the definition of the graph, right? It is the collection of all points where the input is the x coordinate, and the output is the y coordinate, the output is the y coordinate. So we know then our tangent line has to passes through a1 over a, and it has slope negative 1 over a squared, right? So what we're going to do is we're going to take that, we're going to plug this into our equation. Right? And this is the equation of our tangent line, which you might, isn't in y equals mx plus b form, but if you, simplify it, you can get that form if you want. Okay, so you've got your equation of the tangent line. I'm going to let you kind of, fiddle around with that thing from there. And now that you have the equation of this line, you can figure out, right, what its x-intercept is and what its y-intercept is. You could leave it if you want. It's not impossible to determine the x and y-intercept from this form. It's just probably not what most of you are used to, but you do what you like. It doesn't, if you can find the x and y-intercept from this, go crazy, right? So your height here as a function of a is whatever your y-intercept is, right? Because that's exactly what this is, right? The y-intercept is the height of your rectangle, and the base of your rectangle is the x-intercept. So use this equation and find the x and y intercepts. So I mean, it was just like, you remember on Tuesday, I was asked to do something about assignment 9, question 2, and I used the function 1 over x to make the triangle. We're just kind of recovering that. Yeah. Yeah, this is for 2. So Kayla, does that help? Does that kind of make sense? And once we find the intercepts, no, like once you have the height and base of your rectangle, you use the area formula for your triangle, right? Because you're trying to figure out what the area of the triangle is. So once you have the base and the height, you don't have to go back to the line. You can just plug everything into the formula for your area. Yeah, and Brandon, what did you get out? Because that looks right to me. Yeah, it's either going to be tonight or it'll be like tomorrow around noon is when the recording will go up. Sure, Christian, let me take a look. No problem. Yes, yeah, this, oh, okay, yeah, sweet. If you guys did it in tutorial, that's great as well. And actually, the reason I think you probably did it in tutorial is this was an assignment question last year. And so the TAs are not, the TAs love to take things from me. Okay, and does that work, Brandon? Oh, yeah, no, that shouldn't work. Something's weird there. What did you do wrong? -3, -2, 1, 0. Brandon, your third equation is incorrect. No, your fourth equation is incorrect. You have 2 -1s. Why do you have 2 -1s? Okay, Christian looks good for part 1. Good. Yeah, Christian looks great. Okay, my only thing is I don't like you using the implication sign instead of an equal sign, but other than that, right? Just as a math thing, as a mathematician, I have to do this. You want, let me write down something that's not related to the assignment, so I'm not, giving anything away. Don't be afraid to use an equal sign, right? Like this means something different. Just use the equal sign. Don't use the implication, right? Just write equals. But otherwise, it looks great, and just keep going, and you'll get the right answer for sure. Yeah, exactly. Brandon, do you see the mistake? Curdy, are you doing this one? or the actual assignment question when you say this? Okay, the actual, I don't remember what that was. Why was this yesterday too? Yeah, okay, that looks great. But then when you put, okay, yeah, I mean, there's no guarantee that you can simplify further, but it doesn't matter because you can still find your X and Y intercepts from there, right? Your Y-intercept occurs when X is equal to 0, and your X-intercept occurs when Y is equal to 0. And so you would plug those in and solve for your X and Y-intercepts. I mean, you can, Curdy, you just need to right? You have that like coefficient in terms of your like X minus blah, blah, blah. If you expand it out, you do get your Y equals MX plus B4, right? It's just whatever number is like expand out that bracket, whatever number is in front of the X is your slope. Everything else is your B, is your Y-intercept, right? I know. Yeah, the problem, Connie, right now is that I'm getting hit by multiple different people for multiple different questions. So once we have the function for X and Y in terms of A, then directly use the base times height over 2. Connie, you have to do a little bit more, right? Like it depends what you mean by the function for X and Y in terms of A. Like once you have the equation of the tangent line, you can use that to find the X and Y intercepts. Right? And once you have the X and Y intercepts, that's your base and your height. And you can use that to find the area of the triangle. All right. So what you said was just ambiguous enough for me to not be able to give you a definitive answer. Make sure you're using the X and Y intercepts in order to be able to figure out the height and base of your triangle. Is it okay to assume that A is your X? Yeah, you use whatever variable you like. You don't have to use A. Brandon, no problem. I tried to put again the one that C not wrote, but it still gets an unchanged. That can't be right. Let me down check this again. Oh, well, in any case, what is the issue? Kelly, why do you hate that answer? So like what's on the screen? Well, Kelly, you got your vector solution out, right? No, of course there's an X. What you solve for is C0, C1, C2, C3, C4, right? That's what you solve for. That's what that vector is. It's the coefficients. So now plug them back into the quartic equation. Yeah, so Saeem, the question here is like if, let me use white. So if f of x equals 1 over x, show, or let's say, and x is greater than 0, show that the triangle formed by the x and y axes and the tangent line always has an area of exactly 2. Right? And, we set it up. So the steps here were, 1, find the equation of a tangent line. for arbitrary A to find the X and Y-intercepts. Which is the same thing as the base and height of the triangle. And then 3, find the area. Right? Right. So Kelly, what you did, right? Remember, you had your equations, right? And your equations were like the C0, the C1, the C2, the C3, the C4, those were your variables, right? No problem, Sam. And you solved for those, right? So the thing that you got out is, right? The vector that you found is this thing. So you solved for those coefficients, and you know that the function is C4x to the 4 plus C3x cubed, C2x squared, C1x plus C naught, right? So now you know what numbers to plug in, like, if you had, say, gotten 7, -3, 2, 1, 0, then this equation would have been -7x to the 4 minus 3x cubed plus 2x squared plus x plus 0. Do you know what I'm saying, Kelly? Like, you were trying to find the coefficients. You have now found the coefficients. So go plug them back into your function. And then if you want, plot your function and check that it worked. Yeah, you're like 99% there. You just have to go plug them back into your function. Yeah, that should, okay, so for your Y-intercept, so Curdy, take the equation that you gave me, which was correct, and plug in x equals 0. And if you plug in x equals 0 and you solve, yeah, actually, hold on. Maybe you didn't solve for, let me see, what did you write down? Where is it? Oh, what are you doing, Zoom? Curdy, there's something going on. So the answer you sent to me has a bracket mismatch. You have 3 left, or you have 2 left brackets and 1 right bracket. So I can't figure out exactly what you meant to write down there. So can you resend it to me, but this time just with the brackets fixed? I got the value of A in the assignment, but when I try to recheck by using the area of the triangle, they don't match. Well, then that's probably not a great sign if they don't match. Because it should, right? It should get, but like, so you get the value of A. Do you plug A into your 1/2 1 plus A squared, like the value of A that you found, right? Because don't forget, you have to plug that in, right? Once you know what A is, everywhere, if you want to check your answer, everywhere you see the A, you have to plug that back in. Curdy, right. And so that's not the correct thing. Your brackets are in the wrong place. Yeah, double check your computation of that, Curdy. Shanna, you got that, but what do you mean? What do you? Oh, it shouldn't. Yeah, it shouldn't come out to, like, that's the right value of A. So yeah, if you computed it, I mean, that's not true though, right? Like, draw for yourself the tangent line at that point and the triangle, and you can see that triangle doesn't have area 0, right? So there's something kind of weird about whatever computation you did. If you want to write it up and post it on Piazza or something, I can take a look at it. But then, no, hold on. What are you doing? So that's correct. The Y value at that point is that, but the triangle is different, right? The triangle is made by the tangent line. So what I want you to do is draw a piece of paper, draw the graph 1 minus x squared, right? And again, I don't want to say what the correct answer is because I don't want to give that away to any of your classmates. Maybe let's even kind of draw this shallower. Draw the tangent line at the point that you know the answer is. And you can see the triangle is not, it has area, right? Pretty close. Why is it x minus 1? Yes, then that would be right. And now plug in x equals 0, and what do you get? No, so Shani, it is. I think I'm not quite, no problem. See you, Kelly. I think I'm not quite understanding what you're saying. So like, for example, let's say this is the value that we found, right? Because again, I'm going to use not the right number because we don't want to give it away. So this is the A that we found, right? I take the tangent line. I guess see if I can draw that. It looks something like this. And then I draw, I shade in this area here. And let's say this A was equal to 1/2 or something, right? Then I'm saying when I compute this area, the area should be equal to 1/2 1 plus 1/2 squared. And it doesn't, right? Because this isn't the correct answer. But like that's what should happen when you do this. No, Curdy, you plug in 0, right? You're trying to find the y-intercept, x is 0. Oh, yeah, sure. Yeah, sorry. And you can simplify that equation a bit. No, the area is definitely a 1/2 base times height, but you have to figure out what base times height is, right? For this triangle I just drew, right? The base is this. The height is this. Right? And it just so happens that the base is exactly given by the x-intercept and the height by the y-intercept. Okay, yeah, great. Right, okay, perfect, Shani, good. And Curdy, yeah, that looks right. So there's your y-intercept. Now do the same thing, find your x-intercept. And then, well, so you find your x and y-intercepts, right? Then the area is 1/2 your base times your height. So you know what the area of your triangle is in terms of A. Do you know what I'm saying? And then you set that to be equal to the area that you want, which in this case is 1/2 1 plus A squared, and you solve for A. So you'll get the area, right, as some sort of function of A. You want that area to be equal to 1/2 1 plus A squared, solve for A. Yeah, no problem. Okay, everyone, did I hopefully answer all the questions? If anything has quick, we're running out of time, but if anyone has anything quick, I'm happy to answer it. No problem, Devin. See you later. All right, everyone, I think it looks like we're good. So if that's the case, yeah, good luck. Thank you, Brandon. Have a good weekend, everyone. Work hard on your assignment, and I will see you all next week, right? Yeah, right on. Sounds good. Okay. Bye, everyone.